Network, what the hell is this? I wanted to show you a process or a video where your solid is changing. I just hope that video will be able to load up. Where your solid is changing directly to a gas. There's something we call dry ice. You know what? Have you heard of that word before? Dry ice.
Mm-hmm. I don't know how it's made, but I've heard of it. It's supposed to be very dangerous whenever you touch it. Hello?
Can you hear me?
Yes. What happened? Why did you stop?
Okay. Seems like net- oh, seems like network is our enemy today. I just hope it only happens today. All right. Now let me go ahead and explain this. Now, there's something we call dry ice. What is dry ice? Dry ice is just uh carbon dioxide that has been solidified. All right. Carbon dioxide that is in solid form. That is what we call dry ice. Now, dry ice is one solid that you can see becoming gas. Just like what we have here on the screen, this is a solid and a dry ice, carbon dioxide, solid carbon dioxide. If you leave it just in the open, immediately it doesn't melt down to a liquid. It just gradually begins to turn to ice, begin to turn to vapor or gas without going into the liquid form. Another example, another place where you can actually see what's happening is candle wax. You know what's a candle wax?
Yes.
Okay. Okay, you've seen it before. All right. Now that candle wax, there's an extent which you can actually heat maybe a frying pan or anything at all. You heat it so much that once you throw in candle wax inside it, it doesn't melt to a liquid. Immediately it evaporates as a gas. Why? Because the heat of that container is actually too high for it. That process of that solid ice or that solid wax turning directly to a gas is what we call sublimation. We say it has sublimed. Now, an example is when candle wax is exposed to very high heat and it turns to gas that is sublimes instantly without melting. So, different other materials can actually take up that form without necessarily turning to a liquid. They move directly to a gas. All right. And that is what we call sublimation. Now, don't forget, we've talked about melting. We've talked about which is the process of turning your solid into a liquid. Am I right?
Yes.
Yeah. And then we talked about which one again? We talked about evaporation, which is the process of what? Can you remember?
Can you ask what you just asked again?
Can you remember?
Sir?
Can you remember what evaporation is all
Evaporation.
about?
Evaporation. Evaporation is the process of
Okay. Okay, look into your notes, the one I just sent.
Okay, now I get
Yeah, you see the evaporation.
it. No. Yes.
You
It's the
should.
process by which
Okay,
liquids turn directly into gas. But I didn't write it down. Here.
exactly. So don't forget that's the process by which liquids turn to gas. Let me see. So let me see if this network will allow us. I think it's gradually coming back. Now let's see this. Okay, let's hope. Let me hope that this will show. No. Now let's see this. You see what's happening there?
Yes. He's.
You guys yeah. Now,
Yes.
what's happening there is that that guy is turning directly to a gas. It doesn't melt back to liquid. Why? Is because the temperature of the hot water is higher than its actual temperature. So it turns to a liquid, a gas directly. Now, now the network is back, let me show you the other steps. I want for us to see. Okay, let me show you. The other stuff I will discuss. Okay, melting. Okay. Let's look at melting. What happens during melting? Okay, let me search for what's this one. All right, what's this? Those are the solid particles. As you begin to heat it, you find out that they are now moving around. The more you heat, the more they are able to move. At this point, at that point, they now change from liquid. This is when they become liquid. And you continue to heat. At this point, they are not solid because they've been able to gain a high amount of energy. Can you see that again?
Yeah, I can. Yeah, I'm seeing the video.
All right, exactly. That's actually what happens when you heat different particles. All right, let's see which other one have we
Okay,
done.
so it's saying that I blast like lava amount of heat at something, and
Yeah, yes,
it will just skip the liquid right
Exactly. As long as you keep heating it, it turns to gas. Now, I talked about melting metals like iron. Let me see if I will find a picture, a video. So you see how different companies produce different metallic products. Iron melting. Exactly. Okay. I think this should be an okay. Now these are different metals. This is in a company. That place where they put it is called a furnace, where the metals are being heated. The more you heat them, they begin to turn to liquid.
Damn.
You
So
see,
like,
the heat is so high.
damn.
You see what's happening? You cannot pour it into something, into anything, and use it to produce any metallic product, any shape at all. Yeah, I think they want to produce an engine part. So by pouring it into that mold, it takes the shape of that mold so that when they open it, it has the shape of anything inside there. And allowing it to cool down. So that's actually what happens. Different things can be melted, metals, including sand. You know that sand can as well be melted.
Hmm?
Yes,
Sound.
yes,
Sound.
yes. There's a special kind of sand, like your soil, the sand. There's a special kind of sand which is used to make your glass. Everything you learn in science is actually applied in real life. They can actually be applied in real life. So let me see. Let's see this. This is the sand. They pour it in and allow it to heat. Now the heat melts it. So this is not complete. Let me try something that is good. Mm, let me see one that starts from the beginning. Okay, I think this is enough. Now this is what we call glass sand. It's just like the sand, but it's not just the normal sand. They are brought especially from the sea. They can actually be heated so much to melt. And when they melt, they can be used to make different things, such as glass. Let me show you when it has been melted, what it turns into. It can be made into something like this. Exactly. Now, and you see that can actually be used to make different products that you see in the market, including the glass cup you see, including the glass window you see. All of those things are made from sand.
With
The
sand.
type of sand. Called, yes, called glass sand. It can be melted and made into different shapes.
And it's like moldable too.
Exactly.
all from sand.
Okay.
So that
Yeah.
means that if I just go outside to my park, grab sand, and then put it inside of my pot, I can make myself free glass.
Yes, you can make a glass, but your glass might not be as the one they have because it's a special kind of sand. It's gotten from the sea normally. It's not like the kind of sand we see on daily basis.
Oh god. And the thing just changes color.
Yeah.
But the thing is that if someone were to actually touch it, they die, right? Or they just get
Wow.
burned.
That would be your hand would burn, seriously.
Your
Because
hand
it's
will
actually very hot.
your hand will just be burnt to a crisp.
Yeah. Because at that point it's still very, very hot and it's sticky. So it can actually stick onto your hand.
Okay, understand. I
There are
understand.
different shapes that you can make it into. So that's an application of uh, turning solid into a liquid. So it can actually be used in different processes. And this one that we just talked about, solid turning directly to gas, which is called sublimation, right? And then the next that we have here is what we call deposition. Deposition. And what is deposition? Deposition is a process where a gas turns directly into a solid. Now, somebody might wonder, how is that possible? How can a gas turn into a solid directly without becoming a liquid first and then freezing into a solid? But it's actually very, very possible. You can turn a gas directly uh, from gas into a solid. Now, an example is the ice that forms on cold glass window. There are actually seasons of the year when the environment is actually very cold. Sometimes you find out that when you look at a glass window, you see some particles of ice on the window. Those are actually the water vapor that were in the atmosphere. Now, as the temperature became too cold, especially the glass window, once it becomes too cold, those water vapors, once they come in contact with it, they solidify on the surface of uh, that window. So, and that process is called deposition. So, gases are deposited as a liquid on different surfaces. Now, we have here is a process where a gas turns directly into liquid, skipping the liquid into solid, rather, skipping the liquid phase, often occurring with rapid cooling, like water vapor forming frost or ice on a cold window, or soot forming in a chimney. You know what a chimney is? Elby?
What is a what?
A chimney.
Yes, 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 yes. It is like
Okay.
it's basically the vent of a fireplace.
Yes.
Vent of a fireplace.
So, in an actual chimney, where smoke normally leaves from in a kitchen, you find out that when you look up to that chimney, at the very top of it, you see tiny black particles. Those black particles are actually smoke. You know, smoke is a gas. Now, when they begin to hold on to those, accumulate uh, at the walls of the chimney, they begin to turn into soot. And soot is a solid smoke, a smoke that have actually solidified. So that's an example of what happens when, let me see.
Deposition in practice. Let's have a look at deposition in practice.
Well, this one is okay. right. Now this is dry ice, the one I showed you before that can come directly to gas. And look at the temperature, minus 78 degrees, which means it's actually very cold. Now what happens next? And he brings a coin network. Okay. Now that's a penny coin. Now look at what happens.
No, no,
Look at the surface of this coin. As it becomes cold, water particles in the atmosphere begins to turn directly to ice on the surface. Why? Is because this penny coin is actually now very cool.
coin is
Maybe,
like frozen.
yeah. So immediately those water vapor comes in contact with this very cold penny, they solidify immediately, uh, forming ice. And the reason for that is because of this dry ice. It's actually very cold that anything that touches on it immediately becomes cold.
Damn. So if I
So
put
that's
my
actually the
tongue, my
process
hand
of,
is never coming out.
yeah, if you touch it with your hand will become cold. It has a very negative temperature. So that's basically what happens. So this one,
So
as it
if
undergoes
the
it,
coin is cold.
so as this one is undergoing uh, sublimation, that is turning to gas. This one, the water vapor in the atmosphere, is undergoing deposition, turning directly from gas into a solid. That's what's happening there. Mm, who is this guy? All right. So that's it. Now, all of these processes, how do we remember it? Now, watch. This is phase change. When you want to remember it, you can have this triangle where you have your gas, you have your solid, and you have your liquid. You draw an arrow from your liquid to gas, and then from gas back to your liquid. Draw an arrow from solid to liquid, from there, from liquid back to solid. Draw another one from your solid to gas, and then from gas to liquid. Now, once you have it, you can now impute the name or the term for each particular process, remembering that liquid turning to a gas, just like your water, is what we call evaporation. Okay, that's the process of evaporation. Now, when you want to turn that gas back into a liquid, we call it condensation, and that's this process of condensation here. So, from gas, you can as well turn to a solid directly, and that is what we call deposition. That is, gas particles is now depositing as solids. Now, from that solid, you can as well turn directly to a gas, and that is what we call sublimation, just like the one we just watched. Sublimation, a solid turning directly into a gas. And then from solid to liquid, we call it melting, and you are very familiar with that one. You can melt your ice, you can melt metals, you can melt anything, and that is called melting. Then from liquid back to solid is what we call freezing. You freeze your liquid for it to become solid. So this picture here is actually the phase diagram. Now, these three phases that we've talked about, the gas, the liquid, the solid, these are just the basic three phases of every matter on Earth. Okay? Now, when you begin to go high in level, you begin to see other different phases that we don't have only three phases. For example, fire. Let's take flame of fire. Which phase can you put that on? It's not a gas, it's not a solid, and it's not a liquid. All right? So it's a different phase of its own. But at this level, you will be focused on these three phases: a gas, a liquid, and a solid. And then you try as much as possible to remember the terms that is for all of them. All right. Now, factors affecting evaporation. What is affecting evaporation? How can uh, when we want to change something from liquid to a gas, what are the different things that can actually affect that process of evaporation? Then, but first of all, let me see if you still remember. Okay, I think you still remember what we talked about evaporation. That is the process of your what? Turning your liquid to what? Oh, the evaporation, turning your liquid to what?
Turning your liquid to solid.
Evaporation.
No. Evaporation is turning your liquid to gas.
Exactly. Turning your liquid to a gas. That is what we call evaporation.
Freezing.
Evaporation, the process by which
Freezing is the other way around.
you say,
I said freezing is the other way around.
oh, let's say, yeah, freezing is turning a liquid back to solid. All right. Now, the key ideas is how fast evaporation occurs depends on how easily particles at the surface can escape into the atmosphere. Now, let me show you what I mean by how easily particles in the surface can escape. Let's take, for example, you have this guy. This is a water body. Let's say you have a bowl. Let me use a different color. Okay, let's say you have a bowl. Now, in that bowl, we have water. This is water. Now, remember, it's made up of different tiny particles. Different particles. Now, we said there that for evaporation to take place, we said it depends on what? How fast. It depends on how easily particles at the surface can escape into the air. Now, what does that mean? These particles that are at the very surface of this bowl, how fast can they actually turn into a gas by escaping into the atmosphere? That is how evaporation, or that is what affects evaporation. That means if they are not able to escape very fast into the atmosphere, this water that we have here, or this liquid we have here, cannot be able to evaporate fast because the particles at the surface here are not able to escape fast. So you find out that evaporation actually depends on how fast those particles, sorry, how fast those particles can escape into the air. Now, quick takeaway, it happens more when the liquid gets warm and when the air around it isn't already full of vapor. Now, what does that mean? At the very surface, we have other gases. We have other vapor that are in the atmosphere already. All right? Because the atmosphere is not dry, it contains some water vapor. Now, if this atmosphere or this air around the bowl does not contain excess amount of water vapor, it will be easier for this water vapor to turn to gas. But if it contains excess amount of water vapor, it doesn't need any more water vapor. So this one cannot be able to turn to gas very easily because there is already an excess of it in the air. Do you understand that?
Yes, I do.
Exactly. So that is one thing that affects evaporation. Again, is that how warm or how hot is the liquid? If you keep the liquid cold, it cannot evaporate. But the moment you begin to heat it up, it begins to change to a gas. It begins to change to a gas. So that is one thing you need to know about the factor that is affecting evaporation. Now let's look at other things. Let's look at other things. Major factors that influence evaporation. We said temperature of the liquid. Remember how I told you that when you begin to heat it, that's when it begins to change to a gas. So the temperature of the liquid actually determines if that liquid will turn to a gas. Higher temperature leads to higher evaporation, and that is why we heat the water. That is when it changes to vapor. Warm liquid evaporates faster. That is why when you heat the water, it turns to vapor. That is why when you heat your water, it turns to vapor. All right. So that's what we have here. And then the second thing that affects evaporation is what we know as surface area. Surface area. What is surface area? We say here that if the liquid is spread out in wide area, more of it can evaporate at once.
Wait, so
Maybe
does melting also apply to foods?
to food.
Yeah,
Okay.
especially to
Mm,
sandwiches, chicken sandwiches.
okay, you can't really melt those ones. You can't melt those ones. The only one of the food substance that you can melt is something like your sugar. You
Sugar.
can melt, yeah, you can melt
How
sugar
about
when you
wait? How about sauces?
sauces.
Yes,
Those ones, they are already, you can't melt those ones. They are already in liquid already.
but won't they turn into like vapor or something?
Okay, changing to vapor. Well, what happens exactly? What happens there is when you heat it so much, okay, every water that it contains will escape. And at that point, your sauce begins to burn on the heat because every water has escaped. Everything now begins to burn. And when you leave it there for a longer time, what happens is that it changes to black color. It becomes charcoal. It happened to me some weeks ago actually. I I put my pot of rice on fire. I forgot and slept off. Before I woke up, I slept for 2 hours.
Oh,
This is my pot, and I have my rice inside it. I put it on fire over the gas, and the thing heated so much. I never noticed. I just slept off. Now, if I could wake up, what has happened there is that the heat has driven every water particle in this rice. The heat has driven it off. All of them has escaped into the air. Now there is no water to keep this again. It begins to burn. Before I woke up, all of them has turned to charcoal. They burnt, turned black. Even my pot began to melt due to the excess heat. So when you heat that your sauce so much, what happens is that all the vapor, all the water that it contains will escape. Every liquid it contains will escape. Now the rest of the things that are not liquid there begins to burn down. So that's what happens.
okay, I get it.
Yeah. All right. So we have here surface area. We said that if a liquid is spread out in a wide area, more of it can evaporate at once. Now, let me explain what that means. Here, let me say I have two different bowls. This is a different bowl. And then I have a cup. I have a cup. All of them, both of them, the same amount of heat and the same amount of water inside it. You notice this is the one in the bowl, and this is the water in the cup. Now, look at all of this area from here to here. The bowl is wider than the cup, right? Am I right?
It's wider than the cup.
Yeah. So you notice that if evaporation begins to take place in the both of them, both the cup and the bowl, evaporation will start taking place from here, 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 different parts of the bowl, different places. Now you find out that more water will evaporate in the bowl compared to this cup here that has only limited space, or just a small amount of the water is what is exposed to air. But here, a larger amount of this water is exposed to air. So this is what we call surface area. This bowl has a larger surface area, while the cup has a smaller surface area. All right. Now, having known that, what happens there is when you have a larger surface area, just like the bowl that we talked about, when you have a larger surface area, we said that if the liquid is spread out in a wide area, just like the one we have in the bowl, more of it can evaporate at once. Now, but when you have it in a small area, just like the one in the cup, just small amount of it can evaporate at once. Now that means that surface area, that's how wide the area of the liquid is. It actually affects the speed of evaporation. If you even begin to heat up the bowl and heat up the cup at the same time, the bowl will evaporate more. All of the water will escape even before that of the cup escapes. Why? Because the bowl has a higher surface area which can actually allow so much amount of water to escape. Now we have that larger surface area provides more particles at the surface able to escape. Now what does that mean? This is a large surface area that we have here. This is a large surface area. Now, if you want to look at the particles, the amount of particles we have here, we might have a particle here, 1, 2, 3, 4, 5, and as many as you can have here. It can reach up to hundreds of it. But for the cup, we just have very few amount of particles. Very few amounts. Meanwhile, for the bowl, we have so many of it. And because of that amount of large particles that are spread out on the surface area, they can easily turn to gas compared to the one you have in the cup. Just a few of them can turn to gas at the same time. All right. So now, that means that our surface area can affect evaporation. Yeah. Yes. Now, the next. Okay. Yeah.
Can the amount of energy that is being used in evaporation also affect the amount of energy?
Yes, exactly. Remember
To fuel up
to eat it.
evaporation. Can it also affect?
Yeah, of course it can. When we talked about temperature, remember temperature is all about heat, and that heat is the energy. Yes, that's the energy you use for evaporation. So that heat is the energy. So the more the temperature, the more the energy. So of course, energy that you put in can actually affect evaporation. And again, the next thing we have is humidity. Humidity, air humidity. Now, what is humidity? We say here that humidity is the amount of water vapor in the air. It tells us how dry the air is. Now, that means if we have, for example, more water vapor here, let's check this is a particular area. This is Dubai, and this is Nigeria, right? Now, in Dubai, you have just a small amount of water vapor over the air that is just spread out over the air. But when you come to Nigeria, you have so much amount of water vapor all everywhere, many of them. Now, at that point, what can we say? Nigeria has more humidity than Dubai. Why? Because there is more amount of water vapor in the air of Nigeria. we can say that Nigeria is more humid than Dubai. Okay? Yeah. So, since Nigeria has more water vapor in the air than Dubai,